right, so question 7 from yesterday. You were given 1, 3, 5, 7. You guys agreed the next term is 9, right? What's occurring from term to term? I'm like, okay, you're adding 2 to each term, right? Okay, so all we did was transfer it to a table, to a graph, right? I want to find the y-intercept, so you're going to go back a term. So if you're adding to the inverse operation to adding is subtracting, so you're going to go back 2 units. So subtract 2 from 1 gives me -1, right? Okay, if the table, same way, right? If I'm increasing by 2 as I progress down the table, then if I want to go backwards to find the 0th term, I would just inverse operate that common difference. Okay, so what is that called? That common number that keeps getting added or added and added, right, consistently, it's called your common difference, which is the letter D. Okay, so if we're talking about the recursive rule, this is the one you guys forget. Okay, you always give me the initial term. You have to give me 2 things, the initial term and the nth term. Okay, the initial term is the initial, guys, the initial term in the sequence. They gave you 1 first. Right? They gave you 1. So a to the 1 is 1 because they gave you the first term was 1. So you have to give me that. This is the one you guys sometimes forget to write. The nth term, you guys are great with this. Okay. The nth term is a to the n because I want you guys to find the 100th term, the 50th term, the 7th term, right? Okay, it's always the term prior plus the common difference. So let me just write the rule down below. And so what's the common difference that's occurring from term to term? Right, you're adding 2. And so this is the recursive rule. This is just one example. So by next week, you're going to be really, really comfortable with it, and you'll get used to the a sub n's and a sub n minus 1. You got to get comfortable with like what we're writing, but in terms of mathematically, you guys are good with the patterns. Okay. All right. So this is recursive. That's it. Okay. All right. Here's explicit. Explicit is the one that's challenging to you guys. All right. So because this is a linear pattern, so this is a linear pattern, which we'll talk about that more. This is only example 1. A linear function follows y equal mx plus b, right? Because see how this is kind of a line if I was to connect it? So it's a line. What does the m stand for in y equal mx plus b? Slope. What's the b? Very good, the y-intercept. Okay, so if we take the linear, oh, it's blurry in that little section. If I, oh, there we go. Okay, if I just substitute, because remember, this is a linear function, we're talking about sequences, so we're talking about a's and n's, okay? Is the slope is your common difference. It's that plus 2. So this is your plus 2 common difference. Your y-intercept is the value of the term at 0, which is -1. So students, in the beginning, if you were to give me this in slope-intercept form, I would give you credit because you did the hard math. You understand. I can't get upset with you and say you don't understand the concept. No, you do. What do you have to transition to? You have to transition to a sub n's sequencing or f of n's. You just got to change your letters. Okay, so what should ideally be written? an is equal to 2n minus 1. And so this is sequence terminology, sequence symbols, but it's identical to your slope-intercept form equation. Okay, you guys look at a worksheet. Let me pass it out, and then I'll pause this. Yeah, definitely. Okay, let me pause this.